Moon's gravitational pull on the Earth causes the oceans tides, which it does. Demonstrate that the gravitational pull of the Moon on the Earth's oceans is approximately 3/1,000,000th of the gravitational pull of the Earth on its oceans. Assume the distance from the Earth to the Moon is 380,000 kilometres. Alright, so we are on, make sure you can see this, chapter 21.4, question 1b. And previously we've worked out that the mass of the Moon is actually 7.35 times 10 to the 22 kilograms that we'll actually need as we figure this out. So what we've got is a scenario where we've got the Moon and we've got the Earth, and the separation they've told us between the two is 380,000 kilometres, and we already know that the gravitational pull of the Earth on the surface is 9.81 newtons per kilogram. So what we really need to do here in this question is to work out what the gravitational pull of the Moon is at the surface of the Earth. Now to do that is relatively straightforward. We've got G is equal to Gm upon R squared from your formula sheet. G is then 6.67 times 10 to the minus 11. And the mass of the Moon we're using is then 7.35 times 10 to the 22. And we know the separation from the Moon to the surface to the Earth we're told to use is 380,000 kilometres, and that's actually all squared. So that should tell us the gravitational force on the Earth's surface of the Earth from the mass of the Moon. If I plug the numbers in, we've got 6.67 10 to the minus 11 multiplied by 7.35 times 10 to the 22. I've got to divide that by 380,000 times 10 to the 3 squared. Gives me a value G on the surface of the Earth from the Moon of 3.395 times 10 to the minus 5 newtons per kilogram. So what they wanted to do is to compare G from the Earth, 9.81, to G from the Moon, 3.395. So if I look at that, I'm going to go, right, so the relative, I'm going to compare the G from the Earth, and I compare that to G on the Moon. So that's 9.81 divided by 3.395 times 10 to the minus 5. If I plug that into a calculator, what I get is 9.81 divided by the previous answer gives me 288,958. So G on the surface of the Earth from the mass of the Earth is about 300,000 times greater than G on the surface of the Earth from the Moon. Now the interesting thing there was they wanted an answer of 300 million, whereas I've got an answer of 300,000. So there's something slightly different going on, and we've got a factor of about 1,000 in between the two answers. If you have any ideas, let me know. Back, rereading the question, they've actually got 3/1,000,000ths, so we're actually out by a factor of 10. So if you can spot the problem is, let me know.